Kinetics of particle, Newton's second law. Look at these photos. Aircraft and roller coasters can both experience large normal forces during turns. When an object moves in a curved path, we can resolve the sum of the forces acting on it into normal and tangential components. We can also express the object's acceleration in terms of normal and tangential components and write Newton's second law in the form the sum of the force in the tangential direction equal the product of the mass and the tangential component of acceleration. From previous chapter, we know that AT equal dV dt. And the sum of the force in the normal direction equal the product of the mass and the normal component of acceleration. The normal acceleration equal velocity squared over rho. If the path of the object's center of mass lies in a plane, the acceleration of the center of mass perpendicular to the plane is 0, so the sum of the forces perpendicular to the plane is 0. Let's look at some examples. The bob of a 2-meter pendulum describes an arc of a circle in a vertical plane. If the tension in the cord is 2.5 times the weight of the bob for the position shown, find the velocity and acceleration of the bob in that position. The strategy for solving this problem, we have to follow this sequence. First, resolve the equation of motion for the bob into tangential and normal components. Then, solve the component equations for the normal and tangential acceleration, and finally solve for the velocity in terms of the normal acceleration. First of all, we have to draw free body diagram and the kinetic diagram. This is the tangential component. This is the normal component. So for kinetic diagram, we have MAT and MAN. Also for free body diagram, we have weight and also the T. Okay, first we write the Newton's second law in the tangential component. We have the mg sine 30 degree equal mat. We find the tangential acceleration from this equation. And then we write the Newton's second law in the normal component. And we find the normal acceleration. As a previous section, we know that the an equal v squared over rho. So we can find the velocity from the normal acceleration. Next example. Determine the rated speed of a highway curve of radius 400 feet banked through an angle 18 degrees. The rated speed of a banked highway curve is the speed at which a car should travel if no lateral friction force is to be exerted at its wheels. Our strategy. The car travels in a horizontal circular path with a normal component of acceleration directed toward the center of the path. The forces acting on that car are weight and normal reaction from the road surface. We have to resolve the equation of motion the car into vertical and normal component, and finally solve for the vehicle speed. First of all, we have to draw free body diagram and the kinetic diagram. We write the sum of the force in y direction equals 0. We have W and the R cosine 18 degree. So we find the R from this equation. After that, we have to write the Newton's second law for the normal component. And we, instead of an, we write the v squared over rho. When we solve this equation, we find the velocity equals 64.7 feet per second. Last example. The boat, which with its passenger weight 1,200 pounds, is moving at 20 feet per second in a circular path with radius 40 feet. At time 0, the driver advances the turtle so that the tangential component of the total force acting on the boat increased to 100 pounds and remain constant. It continues following the same circular path. At t2 seconds, determine the magnitude of the boat velocity and total force acting on the boat in the direction perpendicular to its path. First of all, we have to determine the mass, the boat's mass. After that, we apply the Newton's second law in the tangential direction to determine the tangential component of boat's acceleration. Integrate the tangential acceleration to determine the boat's velocity at as a function of time. As we can see, at time 0, the velocity is 20 feet per second. Now we find the equation of velocity from the Newton's second law. At time 2 seconds, the velocity is 25.4 feet per second. Now we have to determine the normal component of the boat's acceleration at time 2 seconds. And we find the an equal 16.1 feet per second squared. Now apply Newton's second law in the normal direction to determine the normal force acting on that boat at time 2 seconds. And we find the Fn equals 600 pounds. Thank you for watching.